Okay, so today we're going to continue our dive into the world of GIS by looking and working with tabular data. So we've learned and explored a variety of geospatial data. We know geospatial data has a geographic component to it, some location on the Earth, and it uses some sort of coordinate system to reference that data to a specific point, line, polygon, whatever on the Earth. And each one of these data sets also has attributes, so a database of tabular information about what these points, lines, and polygons really represent. So what we'll do today are a few different exercises. The first one's going to be geocoding. So this will continue on our data creation from last week. We're going to take a table of information and bring it into GIS, but we're going to do it using descriptions of locations. So words rather than coordinates like latitude and longitude. We'll learn how to query attributes. So how do we identify specific data points that meet some criteria we specify? And we can take subsets of our data from our queries. And then we'll do an exercise on joining tables. So this is a process of actually combining tables of information together to say, add new information to an existing GIS data set. So our first step here is geocoding. So what is it? This is where we're going to take some descriptive information about a place on the Earth and then use that description to link it to a location. So a very common one here is if you have a street address. So this is a description of a location, some building or home that has a number, a street name, a city, state, and zip code. And we can relate that to an actual latitude, longitude point to represent. But again, we're just going to take that description like a street address. It could be something broad like a place name. So say a mountain or a national park, or it could even be an IP address. If the physical location of that IP is known, you could geocode a table of IP address. Or building names. Geocoding is a very, very powerful and flexible process, but you're just taking a description of information and using that to put it on a map. The way this works is that you have some database of location information, say a database of actual street addresses and where they are on a map. And then you have an address locator. This is a tool that takes your input, some description, parses out the pieces, say breaks it up into components, and then tries to match that to a location in your database. So geocoding requires an address locator and a database of stuff to compare it with. So these two combined are the geocoding process. The way it does this, and we'll dive into the details, is it assigns scores by matching components of your description. To perform geocoding, there's lots of different tools available to you. We will use ArcMap today, which is a very powerful and flexible format for doing it. In the ArcGIS family of products, you can also use ArcGIS Online or the Esri geocoding services. They consume credits on your ArcGIS account. We haven't really dived into ArcGIS Online yet. Each of you has your own username with a certain amount of credits, and using their geocoder will consume credits off your account. And it's actually one of the most expensive analysis operations to run. ArcMap does not use any of those credits from your account, and you can geocode as many features as you would like. Google, through their API and Google Earth Pro as well, offer geocoding options. So you may also find web services out there. Some look, I'll say, a little sketchy if you go on there, but they are generally calling Google API in some format. So you give it a list of addresses, and it will make create a points data set for you. So there's lots of different options to do it. We'll go through one today in ArcMap. You can build your own address locator in ArcGIS. So depending on the format of the descriptive information, you can create your own reference database and address locator to match things within it. When we perform this in ArcGIS, it requires either an Excel spreadsheet or a CSV, comma separated values file. And it needs the data to be clean, right? It's pretty picky about the formatting. So you'll see things like no spaces or special characters on the field names, right? So the title of each column, but it's very, very flexible and you can customize it as much as you like. Generally what happens is that you provide a table to ArcGIS, you give it an address locator, and also which is linked to a database of reference information. And it will run and match some of these addresses. And depending on the quality of your inputs and your geocoding data, most of them will probably match automatically. It will find some match in your database. If it doesn't, you can go in and manually match each of these locations to a point on the map. And we'll go through an example of that today. So how does this process work? First, what it wants to do is it needs you to standardize your address data format. So whatever that format is, it needs to have standard components. So for instance, we could have a street address like you see here. We could break this up into the house number, the street name, street type, city, state, and that zip code. Then what the address locator is going to do is compare it to all of the information there in its database. And the way it does this is it's going to take each component of your address and it's going to compare that to things within the database. So it will first try to find an address 26376. Then it will try to find a street name called Alpine. It will also search for a street type of lane, the city, Twin Peaks, and so on. And it's going to score each one of these components individually. Usually it gives a score 0 to 100. So if it finds this exact house number, you could have a 100% score. If it finds 26380, it may give you a 60% score, for example. It will then sum all of these scores along with all of these candidates. So it will return a list of potential options. Each one will have its own score associated with it. And it will generally automatically match the one with the highest score first, right away. And you can see in the very small print here, it's found, in this example, 6 different potential candidates. Yep, and then it returns that best match out of the result. So an address locator is what links up or searches through your database of information from your queried address description. So an address locator will have a database of reference information built into it. And then it has rules for how to interpret and locate locations within those reference data, right? So it could say that it knows even house numbers are on the right side of the street in your area. It will also have rules for how much flexibility is built in. So a human could see the letters AVE and know that means avenue. You generally need to tell a computer that those are the equivalent thing. So we can build in some flexibility to it. So again, our workflow here is we're going to build or obtain our reference data. This is what we need to perform geocoding. Today, what you're going to use is geocoding data from the Esri Corporation. So it's from the year 2014. We have purchased data set current through 2016. And they're a very, very good reference data sets. So we have our reference data, and then we have our address locator style. So it may evaluate street addresses, it may evaluate and match zip codes or FIPS codes or a number of different things. And then we perform this locating and rematching step. The reference data, like I said, we'll be using Esri's reference data today, but some other places you can go. The census and Tiger data are commonly used, or some sort of gazetteer or atlas databases, like the NavTech. What's really cool about geocoding is that we can link each record not just to a point, but it could actually be a linear feature like a road or a polygon. So if you have zip codes, a table of data you've obtained at the zip code level or the census tract level, you could have a reference data set consisting of polygons and actually match those records back to all of the zip codes. So this is one of the really neat things about geocoding here in ArcMap. Any questions on this process? Conceptually making sense? All right. So what we'll want to do, let's take a look at the data we'll be geocoding and working with today. So on our machines, we've copied over the data onto the D drive. So let's open that Windows Explorer, that little folder icon there in the lower left corner. We'll navigate to our D Data 2 drive, there on the left under Computer. And you should have a folder working with tabular data. And if you open that, you'll see two folders. Each of those has a .gdb extension. So we know those are actually file geodatabases. The tutorials for today, those PDF documents are all here. We have a map document we'll get to later. And then the data set we're interested in is this Excel comma-separated values sheet, a TRI Facilities 2014 raw. So let's go ahead and open that in Excel and just take a look at the data. I'll also show you where these data come from. Is anybody already familiar with TRI Facilities? Nope. All right. Let's see. On my second desktop here. So the TRI stands for Toxic Release Inventory. And the EPA requires permits from facilities who discharge hazardous chemicals to the environment. And as part of that permit, they need to report the mass of each chemical that they've released. So from the tox mapping service, you can go to the TRI facilities. You can zoom to a specific location, say South Carolina. Whoops, not what I wanted to do. Is it going to zoom to South Carolina for me? Guess not. Anyway, you can click here to download and save all of the facilities that are visible in a map, and it will give you a CSV file with that information. So that's what we're going to start with today. So these are facilities that have discharged some sort of chemicals to the environment. So if you have your table open, let's take a look at it. First, just take a look at each of these columns and let's see what information is available to us. And tell me what sort of location information is provided in this table. Like, what can we use to geocode?
Address, city, state, zip code.
Address, city, state, zip code. That looks pretty good, right? So here we have an address, city, state, zip. So if we have an address locator that matches street addresses, we could use that information. Is there anything else you see? lat long, right? So we did that last week, right? We went through and we took a table of coordinates like latitude, longitude, and used those to place on a map. So what we can actually do here is compare the two outputs we get, and we will do that. But we'll use this address, city, state, and zip information. So you can see there's also a name of the facility, a facility ID code, and as I scroll to the right, there's this Chem 1 amount, Chem 2 amount, and so on. These are the names of different chemicals that they've released, and then a mass, I believe in pounds, that each one's released. And so they have up to the top 5 chemicals released by mass in this table. So what we need to do is clean up our data before we even bring it into ArcMap. So some of the most common things that we'll need to fix are any special characters in the headers of our columns. So the only one that's allowed is an underscore, no spaces, no question marks, ampersands, asterisks, and so on. So as you look through the names of each of these, we're going to be inspecting this row 6 for now. So are there any of these that look like they might cause us a problem?
I'm just curious, what was the units?
The units of the chemical?
Yeah.
I believe it's a mass in, or a weight in pounds. I think. I haven't looked since 2014. But I believe that's the unit here. So does anybody see anything that might cause us a problem as we go? Which one? Where? Other amount. Yep. So over here in column W, we have asterisk, other amount. So let's just remove that asterisk. Any other problems?
Hyphen in last year.
Hyphen in last year, right? So column K, we have last hyphen year. We want to change that to an underscore. Anything else? Facility ID, yep. So our column A, FAC ID, we want to change that hyphen to an underscore. What else? Anything? Looking pretty good. So you may see some interesting displays of Excel here in the data. It's using scientific notation for those 9-digit zip codes. Those aren't a concern to us. Any of these pound signs or hashtag symbols, whatever they call them now, these are actually a number. It's just the row is too narrow to view. What else? The other thing we need to do is we need to remove any rows in our table above the header of our column. So when we download the table, it tells us, it gives us these first 5 rows of information. We need to actually remove those because ArcMap wants the first row in your table to be the name of your columns. So I'll go over here in the left, select rows 1 through 5 just by clicking and dragging over here on the left. And then I'll right click and click on delete and remove those rows. Kenneth, did you have a question?
Oh, yeah. So you have errors in the observation data, but you want to keep those observations for other reasons. Let's say line 16 had an error in the latitude or longitude. If you want to keep it, do you need to go in and clean that and just make it empty cells? Or you try to geocode it? Or like if there's an error in the address or something? Or I want to keep that observation from my sample.
If you relating to an error in the information, are you saying there's an error in the actual location information or an error in the, say, the other attributes?
Not applicable. So like if one of these observations had an MA or city, but I want to keep the name, address, and try to find it that way. Cause any problems or just to
Okay, so if any of the location information is not there, like a city name, and it says NA, if it truly is not applicable, you would remove it, or you would need to go in and figure out the city for that record. Because the format the locator will use needs a street address with all these columns. So you need to go and actually provide that. So there may be a little bit of work ahead of time to clean through your data. We give a workshop in a tool called Open Refine, which is it's an open source tool. If you work with tables a lot and you get them that are very messy, this is a great tool for actually cleaning and standardizing and reformatting and a number of other things, tables. So geocoding is very particular in the tables it will work with, and that's a great pre-processing tool.
What's the name of that?
Open Refine. You can just Google it and download it for free. All right, so it looks like our table is pretty good here. Let's save a copy. So I'm going to go to the File menu and click on Save As. And I will browse to a location. I'm going to save it here in my Data to D drive in the Working with Tabular Data folder. I'll continue to save it as a CSV file, but I will change the output and remove that underscore raw and call it underscore clean. So TRI Facilities 2014 clean. And then click on Save. So once I've done that, I can close Excel. And it's asking me, I've already saved it. I don't need to save again. So here's my new spreadsheet or comma separated values file. ArcMap and Excel both like to lock your data while they're being used. So if you go back and forth between ArcGIS and Excel a lot with tables, you may find when you open one that it's locked for editing by another software. So unfortunately, you often have to close ArcMap to work back in Excel or vice versa. Now we've got our data cleaned up. Let's connect to our reference geocoding data. For those of you who are here in the lab, we're going to connect to a network drive. The geocoding data are stored on the library's network drive, and I'll show you how to connect to that. For the remote participants, this was in the data that you downloaded already. So what you want to do is open your Windows Explorer, go to the computer here on the left, and then at the top is a map network drive option. So from the Windows Explorer, I'll click computer here on the left, click map network drive. And you're going to get this dialog right here. The drive letter doesn't matter. You can just use the default, probably the letter Y. The folder you're going to type in, I guess I've called it address. It's \\\, and the backslash is the key above your enter key. So \\\, libstorage.clemson.edu/GIS. So once you've typed in that address, you can click on finish and it will prompt you for a username and password. Use your username with @clemson.edu. Mine's already mapped, so it's not going to prompt me. But I'll come around and just make sure everybody's able to connect to it. Everybody's saying access is good. Click on use another account. Try your username with g.clemson.edu.
That's what I did.
It used to not work with that G. I don't know what's changed. Good.
No, no, Different,
Yeah, the drive letter is different.
maybe, yeah. Where's that slide? Okay, okay, no worries. Yeah. Awesome.
Good. Is anybody not connected yet? All right. So this is our library's network drive where I store a lot of the workshop information. So from here, if you scroll down in our list, you can see workshops. But what we're looking for is about halfway down, Geocoding Data 2014. You can double click, go into there. There's the Geocoding Data folder. And what do you see within this directory? I started noticing there are files that have the same name and different extensions, which I expect for GIS data by now. So these are different address locators. So you can see there's a street addresses, a city state, zip code, USA service, and so on. We'll connect to this folder in ArcGIS. I just wanted you to see where these files were actually located. We'll leave them on the lib storage drive for now. So now let's open ArcMap. So I'll go to my All Programs. From the Start menu, go to my ArcGIS folder. Click on ArcMap 10.5.1. And once ArcMap opens, you can close that business analyst desktop notification window if you receive it. And we want to connect to those two folders. The first one on the D drive, the Working with Tabular Data folder. The second one will be on that letter, probably Y, but that GIS network drive, the Geocoding Data 2014 folder, and the Geocoding Data folder within that. All right, here's my ArcMap window. I'm going to disconnect a few of these. So to connect to a folder, I'm going to open my Arc catalog window if it's not already. I can find it here along the right side of my screen or here along the top middle. Click on catalog, and I like to click my push pin to prevent it from closing. And I'll click this folder plus sign icon there at the top, connect to a folder. And I'll first go to my computer and expand that. On the word computer, click on Data 2D and scroll down my list till I find Working with Tabular Data. I will click OK. And I'll right-click my folder connections, click on Connect to Folder, go to Computer, find that drive labeled GIS. Down near the bottom, click on that. Find the Geocoding Data 2014 folder, expand that, and then click on Geocoding Data folder, and then click OK. So the drive I'm mapping is Y, Geocoding Data 2014, Geocoding Data. Again, for those of you remotely, your geocoding data are within your Working with Tabular Data folder. Everybody there? Anybody need to see those steps again? Which one?
Just we got the GIS folder.
Sure. So,
Data two.
okay, so we'll go expand your computer option. You'll need to go out of the data two and then scroll down till you find that GIS. Geocoding data 2014. Everybody else good? Cool. All right. So if we expand our working with tabular data folder connection, we should see our tables, those CSV files show up. ArcMap will interpret those as some sort of geospatial data. And we can drag and drop tables into ArcMap. And we know we did that in the last session, but here I'll go to my TRI Facilities 2014 cleaned.csv, and I'm going to drag and drop and release that into my data frame here. And again, my table of contents will change from a drawing order view to a listing by source. If I switch back to the default, the drawing order view, it will not show me that table because there's no geographic component to it. It's just a table. But we can right click and on our table over there in the table of contents, it's a lot of tables, and then click open and view it just like an attribute table. So here I'll dock by dragging and dropping my table onto this blue dock point so I can see all that information from before. Looks pretty good, right? And now I have a column for the facility ID, name, address, city, state, zip, and so on. So that all looks good to me. I can close that table. What it does with drag. Yeah, that's it. Right, you get it. We regular data. Just like that. Oh, okay. Okay, a little quiz from last time. Our geocoding tools are a specialized set of tools in ArcMap. Where would I most likely find them? Possibly in the Arc toolbox. Right click up here in the open space.
Yeah.
Yep, and I'll get a list of toolbars. All right, so last time we added georeferencing in editor. If I scroll down, here's my geocoding toolbar. And this will have the information we need. So I'll click on geocoding and try to find where it's popped up. Here it is. So our geocoding toolbar will show up. Here in the left is a drop down. These are available geocoders, and the software has built in that Esri World Geocoder, which again wants to use credits from your ArcGIS account. So we don't want to do that one. We're going to bring in our own. Let's expand that geocoding data folder connection over in the Arc catalog. Yeah, just duplicate my screen here. So I'll go over to my geocoding data folder connection. And now I see these little house icons, right? So that's what an address locator looks like here in ArcGIS. And I know that actually contains 3 different files within it. Let's drag and drop this one called street_addresses. And you can just release it in the data frame. And my geocoding toolbar now has here in your address locator that street addresses. Everybody there? All right. So to perform our geocoding, we want to click this mailbox icon here on our geocoding toolbar. And this will ask us which geo or address locator we want to use. We'll select street addresses and click OK. And then it first wants to know what's the table. So there's only one table in our map document, our TRI facilities. So we're already set. This particular address locator wants a street or intersection, city, state, and zip code. So we need to tell it which columns in our attribute table contain those. And because the software is smart enough to guess, the addresses in the address field, city, state, and zip are all there. I'll point out that for this particular address locator, those data need to be in separate columns. So if you had city and state in the table in the same column, you would have to go through in your data cleaning step and separate them. So generally, every component needs to be in its own column for this to work. Yep.
So that's my last question. So if we don't have no data at all, could we not use this address locator?
If we didn't have the zip code at all, I haven't tried it. I don't know if it would fail or it would just give you scores based on all the other fields. So the more information you can give it, the better, obviously. We could try that later and see what it does. I'd be curious to see. So down here under our geocoding options, near the bottom of the screen, let's click on that. Here we can fine tune our address locator. So here we have at the top a spelling sensitivity, a minimum candidate score, and a minimum match score. So if we want to be very, very picky, we would increase all these values. If we want to be more accepting of things that don't match perfectly, we can turn these values down. So we want to match as many things in our table as possible. So we'll set all of these to 10. Our spelling sensitivity will turn down to 10. Our minimum candidate score to 10, and our minimum match score to 10. So that's very, very low. If you were doing this, for your thesis, you'd want to be much more critical. But we just want to match things. Yep.
Do you have an idea of how it, calculates spelling sensitivity? Is that gonna, is that just gonna be like first letter is the same?
I don't know exactly. My guess is it's going to evaluate the whole string of characters and allow for some differences, but no, I don't know exactly. We'll just make sure all of these are set to 10. We'll accept all of our other options here. We need to set an output for this, so we can save it as an output, a shapefile, or as a feature class. So I'm going to save it as a geodatabase feature class. I'm going to browse by clicking this folder icon here. And I'll save it in my Working with Tabular Data folder. But I'm going to create, oh, no, I've already created a geodatabase, right? TRI Facilities 2014. So under my lookin, I'll go to my Working with Tabular Data folder connection, double click my TRI Facilities 2014 geodatabase to go into it. And I need to rename it because geocoding result is a terrible name for an output. I will call this TRI underscore facilities underscore 2014. I'll give it underscore GC or geocoded. And then I'll click save and make sure that the output looks correct. Looks good to me. So once you click OK, this is going to perform the geocoding and it will give you a results window. Don't close that window. But once you're ready, go ahead and click OK and then leave this open. And take a look at the results. So how many matched? 88% matched right away. And we had 25 or 5% of them that tied. So there were more than one candidate that had the equivalent score. And then we had 37 or 7% of them that it couldn't match. It didn't find at least 10% score. What we want to do is click where it says rematch. So this will open our interactive rematching session. So here's my interactive rematching window. I'll try to expand this a little bit. But what we see here on the top are points that have a 0 score. And the first row with the object ID 6 had the street shown here in the left-hand side where it says street or intersection 12 Ed Needham, city Mansfield, state Georgia, zip 30055. It did not find anything to match that. So this is one that we want to manually match to a location. So what we'll do is let's add a streets base map to ArcMap to help us locate 12 Ed Needham Drive. So where do I go to add a base map? Say it louder. The little plus sign at the top. Yep, my add data has this triangle next to it for a drop down, and then I'll click add base map. And let's grab the streets base map. We'll click on streets, click add. And I'm going to open Google Maps really quickly. I'll search for 12 Ed Needham Drive, Mansfield, Georgia. And it says this is where that is. Beaver Manufacturing, Mansfield, Georgia. So I can see it's southeast of Atlanta. If I take I-20 east till I hit Highway 11 and go south, I'll find Mansfield. So I'll minimize Google Maps now. I'm going to minimize my interactive rematching window here in ArcMap. And it'll go down to the corner of my screen. I can see the results. So here's all sorts of points all over South Carolina, a little bit of North Carolina and Georgia. I want to try and find Mansfield. So I know it was southeast of Atlanta. I'll zoom in a bit. Taking Highway 20 out till it hits Highway 11, which is just east of the town of Covington. So if I go south on Highway 11 here from I-20, I'll see another intersection near this railroad, and that's Mansfield. And I'll continue zooming in till I have out, zoom in a little further, and I'm going to bookmark this quickly so I can come right back to it. Call it Mansfield. So zoom in until you have about this extent. But how many of you need to see from the beginning again? How to get there? I'll go back. So I will zoom to this extent, and then I'm going to find Atlanta and I-20 heading out to the east. And east of Covington, Georgia, is Highway 11. And where Highway 11 intersects some railroad tracks is Mansfield. Everybody there? So I'll go back to my Mansfield bookmark. And now I'm going to maximize that interactive rematch window again. What I have down here near the bottom is an option to pick an address from a map. So if I click on this, and again, minimize my rematch window, now notice my cursor has this small blue circle on it. And everywhere I click, it's going to give a little pop-up window with an address on it. And so again, for my interactive rematch window, I clicked at the bottom, pick address from map, minimize my window. And now as I click and hold that mouse button, it'll pop up with that address. So I'll bring Google back really quickly, zoom in. Here's 12 Ed Needham Drive, right by the intersection of 213 and Ed Needham. If I zoom in here, here's 213, 11. But what does it look like I have for an address? So as I click in that location, it's telling me it's on what? Pine Street, right? So at some point, Pine Street became Ed Needham Drive. It's not clear when, but I know what I'm really interested in is Pine Street. Is everybody there? So if I open my interactive rematch window, I'm going to go to that street or intersection here on the left and delete Ed Needham Drive. And I'm just going to change that to Pine Street. And then I'm going to click search here in the lower right-hand corner. And here it will give me all of the candidates. So there's one here at the top with a score of 100, 12 Pine Street, Mansfield, Georgia, 30055. And I think that's the one we want. So once I've clicked on that first row, I can then click the match button here on the lower right, and it will fill in that address up here in my table. So how many more times do we have to do this? 36 more times. So I hope you're all ready for a super exciting next 2 hours. They're like, is he messing with me? Yeah, we won't go through the process, but just to demonstrate, this is how it's done. So for all of these that don't match, this is the type of process you can do interactively or manually search for addresses if you have some other place to look. So once I've done that, I'll click close in my interactive rematch window. And here's my geocoding result under my layers in the table of contents. So I'll right click on that and click on zoom to layer and take a look at it. I can also open that attribute table if I right click, select open attribute table. And I have all the information from the source table, but now it's also added on a score, a match type, the side of the street, a status, M means matched, and the address to which it matched it. So that may be slightly different than the address in our original data set. So what do you think? Scale of 1 to 10, geocoding, how difficult was it? You'll probably do it again. The key here is that we had an address locator and database provided that are very high quality. It's not necessarily difficult to create on your own, but it does take some effort to create your own address locator. Let's also add our table as we did before using the latitude, longitude information and compare the two. So some volunteer is going to come up and show us how to do that. You're all going to look away from me as hard as you possibly can. Who remembers how to do it? Bring in a table of latitude, longitude. All right, we have our volunteer. And what's your name?
Robin.
Robin's going to show us how to do it.
What are we doing?
We're going to add our TRI facilities cleaned CSV file as
This.
Yep, a lot of things to look at. So we're going to bring it in using the latitude, longitude coordinates. Tell us what you're doing as you
So
go. People can holler out and help you.
yeah, because I do this using the same one that we did before, using the same thing.
Yep, same table.
Okay, I hope I'm a hack. So I right click, on the table and you display XY data,
Yes, exactly.
and then you go and it knows what my X and Y data are. Are we in the right coordinate system?
Which one has it picked for us?
WGS 1984.
What do you say, audience? Yes, and probably.
If we're matching it, trying to compare with the address locator, does it have an underlying coordinate system?
So again, when we're having XY data like this, we need to know the coordinate system our X and Y refer to. So latitude, longitude are going to be our X and Y, and
Yeah,
yes,
that'll be
these are in
WGS, right?
WGS 1984. So this is an
Correct.
appropriate coordinate system.
I just hit OK.
Click OK.
Oh yeah,
We
that's
get a
fine.
message, we can accept, and then we have that events layer added to the map.
Yeah.
Thank you, Robin.
Oh, yeah.
Like I said before, they only get harder as we go, so volunteer early. So anything you notice, mine are pretty much the same color, so I'll open my symbol selector, change my color to something contrasting. And what do you notice? There's some discrepancies, right? So some line up spot on, and others are off a little bit or even a lot. So what's going on between these two data sets? Maybe I'll ask this, which one do you trust more? Latitude, longitude, where we have an exact coordinate for each of these. The other one is taking some description of where that is based on some database of street addresses. And so depending on how accurate that information is, we could be spot on or off a ways, or it may not even locate. But for a lot of people or a lot of data sets out there, you don't have a specific coordinate. And geocoding is an awesome way to bring it in. How many of you have geocoded before? Ken has one. So how many of you think this is something you would want to do in the future or could see a use for it right away? And what are you thinking about?
I do a lot of like park stuff,
Mhm.
so I look at crime in parks. So, geospatial, like you can easily map crime in spaces or in the places where crime occurred, address-wise, because all that's available in different databases.
Mm-hmm. Yeah, so an address of all these different crime events that may not have that coordinate information, you can still bring it in a map.
Right.
Yeah. Any other ideas? People who study history do this a lot, and they run into this very real dilemma of things change names all the time. Cities, towns change names. They go broke and close the town or move it around or whatever. And so it becomes very complicated, but again, it's a very powerful tool.
So you're talking about creating geocoding data. How would you go about that?
There are, within the toolbox are tool sets for creating those each step of the way.
Okay.
If I wanted to export and save that events layer, that XY data, to its own feature class, how did I do that? So if I want to export a data set, I can either make a copy of a data set or make this events layer permanent, right? It's only going to live in ArcMap for now. If I wanted to make it a permanent feature class in a geodatabase, how did I do it? What are you going to guess to try first?
Right-click export data.
Right click, yes. We'll right click our layer over here in the table of contents, go down to data, near the bottom of the list, and the export data option. And so this will either create a copy of an existing shapefile or feature class, or allow us to export our events as a feature class. So let's go ahead and do that. We're going to export all features using the same coordinate system as the source. We'll go to our output feature class and save this by browsing. We'll save it in that TRI Facilities 2014 geodatabase. within that working with tabular data folder. And this time I'm going to call it TRI_facilities _2014_XY. Differentiate it. And then I'll click save. And then click OK. And you can add it to the map as a layer.
So when we geocoded it, it automatically saved it.
Yes, when we geocoded, remember we specified where we wanted to save that output as its own feature class. Yep. So I'll go back to my table of contents to my.
Yeah, I won't say either.
Sorry?
I won't say.
What is it giving you an error? Oh, you need to be inside the GeoDatabase. So double click and enter the GeoDatabase. Yeah, so double click on TRI facilities. Oh, okay. Yeah. The soup can is like a folder, so I call it the same thing, but kind of click on XY.
So I accidentally saved the original, the geocoded one. Is there a way I can go in and delete this one, or do I just have to save it as like X2? Because it's in a geodatabase, so it's not. So I can use the file.
Yes. So what do we use to organize, preview, manage, rename, delete our catalog? So what you want to do is go to your TRI facilities geodatabase and expand it. And you can right click on the feature class you created and click on delete.
And that actually deletes it.
Yep. And then you can export again. Does everybody have those two data sets now? And I'm going to go to my list by drawing order here in my table of contents. And I'll turn off my geocoding result in my events layer and just leave on that XY data set.
I can see the XY was on that side, and I can't see it over here.
Did you expand that TRI facilities geodatabase? So if you click that plus sign next to it.
Oh, there. Okay.
Yep. All right. Cool. So then we have geocoded. You are now professional geocoders. The next thing we're going to do is talk about querying tables. So querying is one of these very standard but very powerful database functionalities that GIS as an information system also has. So when we query, what we're really trying to do is identify specific features in the data that meet a criteria or some set of criteria. So we're going to identify this subset of our information. So they can be simple things here at the bottom where it's some polygon with an area greater than 20 units. They can be a little more complex, combine multiple statements together. So identify those with area greater than 20 and less than 50. So multiple criteria combined. The way we generate these our selection statements is using the structured query language, or SQL. And we generally build this type of statement here in the middle. We're going to select from our table of attributes where a field equals some value, or is less than some value, or greater than some value, and so on. But here it's going to give you a subset of your data that meet those conditions. So we often want to say identify. We often want to identify some subset of our data, so we can analyze some sort of pattern spatially, or we can subset to perform some sort of processing on just that subset of data. For instance, if we're looking at trees, and we know we have, say, species information. Maybe we want to see if there's a specific cluster of trees in one part of our study area. We can identify based on that species. We could also perform geoprocessing tools just on that subset of data. And you can also export a selection of data to its own feature class or shapefile. So we can leverage that selection a lot of different ways. The SQL uses these different types of algebra. So the set algebra uses things like equal than, greater than, less than, not equal to. And these can be evaluated on both numeric values and on strings of characters. So capital A does not equal lowercase a, for instance. There are also Boolean algebra, or these logical statements. So things like not, and or are all different ways of evaluating combinations of statements. So if they are true, they will return some subset of features. Where here we have not accepts values from one and not the other, and requires two or more criteria to be simultaneously true, and or allows any of a number of criteria to be true to identify a feature. We can use parentheses to build these statements, just like we can with normal algebra. So it will evaluate specific parts of your statement first, and then the rest. So let's take a look at these here. If we have our regions represented by the circles A, B, and C that overlap in this Venn diagram style, what would our statement A or B select? Like, what regions of these circles would be selected by A or B? The two top circles, yep. So everything contained within region A, or everything contained in region B, but it's going to leave out this part on the bottom, right? Exactly. How about A and B?
Sliver, right?
The sliver here in the middle. Let's see. If we select A and B, it's just going to be those overlapping portions. If we have A, not B, just this sort of half moony looking part, it's excluding the sliver. If we have not A or B,
C, but just like the one that's not.
C, but just a part here at the bottom. So it's going to evaluate first, notice our parentheses, A or B, this region here, and then do not. So the inverse of that. And then if we have A and B or C, the sliver plus the bottom. Bingo. Making sense?
So it just progresses like sequentially. Right, so A and B is not.
Function.
It is like an if, right? So we're evaluating whether something is true, but also it's logical. So it's not just going to give a 1 or 0, but some records. So let's try it out on a table of values then. We have some information about different areas, both their size, their land use type, and the municipality. So how many records would be returned from a selection where our area is greater than 20 units? It's equal to 4. Yep, so we'd have 2, 4, 5, and 6. All of these have an area greater than 20 and would be returned. And those highlighted in blue are selected set of entries. How about all of our urban land use? How many records would be returned? 3. Yep, so records 1, 5, and 7 all have land use equals urban. What would our statement look like with find all records with area less than or equal to 55. If we were to write that out, it would be area, right? And then less than or equal to sign 55. So how many of our areas fit that? 5. Yep, 1, 3, 5, 6, and 7. For non-urban land use, what is that statement going to look like? How would we search for, what would our statement be to find non-urban land use? Land use not equal to urban, right? So if you see these less than or greater than signs pointing out, that generally means not equal to. All right. We can compound our queries, right? So we can nest these queries into one another. So if we want to find municipalities that are not urban cities, what's that going to look like in terms of? What are our statements we need to evaluate to do this?
The urban and city, not urban and city.
It's land use, not urban.
So let's see, we want not urban, so
It'd be not.
land use not equal to urban.
Right.
Cities, so our municipality equals city. And then how are we going to combine these two? And, right, we need both of these statements to be true. So land use equals urban. Oh, and we forgot our last part here. So we've set it up here where we could have also done land use does not equal urban. But in this example, using a not concept. So finding the inverse operation. All right. Does everybody feel pretty good with this? We have a lot of examples. I'll just move through and talk about some other statements we can use. In is like stringing together consecutive or statements, where here we're going to give a set of values and then select features that are equal to any of those, right? So rather than searching for state equals Alabama or state equals Alaska or state equals California or state equals Florida, we could say state in this range. The like statement is combined with wildcards in a variety of ways. So you can do partial string searches where, let's say, you know, your state started with MI, but you can't remember if it's Michigan or Minnesota or Mississippi or Missouri. You can do a wildcard search represented here with that % to search through all those remaining characters. And that will return anything as long as it matches this capital MI in the first two characters. You can represent multiple characters, say search anywhere within a string, like using that wildcard symbol at the beginning and end of your search. The exact symbol that's used depends on whether it's a shapefile or a geodatabase feature class table. So it'll either be a % or an asterisk. A single character would be represented using an underscore or a question mark. So if you know the first name you're interested in ends with Airy, but you can't remember if it's Barry, Larry, Carrie, Harry, Mary, or so on, you can search for just one character out of that list. So there's some flexibility built in. This is the window that's actually used, your select by attributes window. So you'll specify the layer that you actually want to query or select from, and then there's a method associated with that. You can create a new selection. You can select from already selected features. You can remove from a selection or add to. And then there's this dialog here where rather than typing in to build our statement shown here at the bottom, LU code equals 22, this interface gives us a way of just clicking our mouse to build statements. So it will prevent us from doing things like typos. Yep.
Is the is equivalent to the or it's like a
No. So for instance, if I was trying to find null values, it generally doesn't like equal to null because it just means it's undefined, but land use code is null would return those values. So this interface gives us a way we select our attribute from our fields, we specify our evaluators, and then we can also grab values from that field just by clicking to build our dialog. Okay, so any questions on querying?
When you double click on that LU code, does it automatically put the quotations in there, or do you have to?
It will put them in quotations because it's referring to a field in the attribute table.
Does it automatically?
Yeah, it'll automatically populate them as needed.
I think sometimes I've actually put the quotation in as that.
Any other questions? No. All right. Why don't we pause at this point before we dive into the exercise? Feel free to use the restroom, grab a coffee upstairs. We'll come back in, what time is it right now? 2:19. We'll meet back at 2:30. All right. So we're going to query and do lots of querying with our TRI facilities XY data set, the one we generated from our add XY data, simply because it doesn't have those extra geocoding attributes. So let's right click and open that table. So I'll go to my table of contents, right click my TRI facilities 2014 XY and open the attribute table. So hopefully by now you know where to go to open attribute tables, and we remember we can do things like sort. We can right click the headers of attribute fields, we can sort them. Say to sort my names ascending. We have lots of basic table functionality. Let's see how we're going to query this attribute information. Our first one we want to do is let's identify which of these facilities are located in South Carolina. So we have 500 records in our table across multiple states. What's our selection query going to be if we want to identify just those in South Carolina?
South Carolina?
What?
Equal to South Carolina?
What equals?
Oh, yeah.
State. Yep. So we have our state field. If I sort that ascending, I see Georgia, North Carolina, South Carolina. Yep. So we just want to identify those where this entry in the state field equals South Carolina, or SC to be exact. So to build that attribute query, we'll go up to our selection menu here at the top. We'll click selection and select by attributes. And that brings up our window here. So in our layer drop down, you see we have different options, but we'll select in TRI Facilities 2014 XY. And now we're going to click and double click on things to build our query. Our method will be create a new selection. You can see those other options, but create a new selection. And I'll scroll down my list until I find that state field, and then I'll double click it. And then I see state shows up here in my query. And we said equals, so I'll click once on the equal button. And now if I click on get unique values here in the center, it's going to read through the state attribute field and tell me every unique value in it. And I can double click on SC to add it to my selection statement. So notice these single quotes here around SC indicates it's text. A really useful tool here is this verify. So if you click verify, it's going to read through and make sure you don't have any typos or other syntax errors. It will also tell you if your syntax is correct, but there's nothing in your data that meets your selection. So the expression was successfully verified. Go ahead and then click OK and then click apply and tell me how many facilities there are in South Carolina. 167, 267. I'll click apply. And how do you know? The bottom left corner down here tells me 267 out of 500 selected. Let me close my geocoding toolbar. I'll move my select by attributes window. So notice what's happened. From my data set, all of those records that are now in that selected subset show up in this bright blue selection color. Here, if I start scrolling through my table, because I've sorted mine alphabetically by state, I notice all of those down here at the bottom, where state is SC, are also highlighted in blue. If I go to my table in that lower left corner next to the number 267, I can switch back between showing all records and showing a selection or selected records. So if I only want to see records that are selected, I can do that here. So we had 267. From my selection window, or sorry, my selection menu here at the top, I can go to selection and then click on clear selected features. And notice as I do that, all of those records are gone in my attribute table unless I go and show all the features again. So I can quickly apply that change to bring it, or that query. See 200 records. I can also clear my selected features from my attribute table. So here along the top is a clear selection option. I'll close my select by attributes dialog here. And I want to show you another really useful feature related to queries. There's a something you can do called a definition query. This is something you would want to apply if you only want to show a subset of your data in the map, but you don't want to delete any data from the data set. You can apply a definition query so it will only show those features meeting the query without actually removing any data from your feature class or shapefile. So for instance, if I add this feature class to the map and now I only want to show those facilities in South Carolina, but I don't want to actually remove or delete North Carolina and Georgia, what I want to do is go to the layer properties for that TRI facilities 2014 XY. I'll right click its name in the table of contents, go down to the properties. And I'm going to go to this definition query tab. And here you can type in the box to build a query or click on Query Builder. And you get something very similar to that Select by Attributes dialog. So let's set up that same query. Double click on State. Click Equals. Click Get Unique Values. Double click SC. Click on Verify, make sure I did it right. Click OK. Click OK, and then click OK again. Notice here in the map, it's only showing those records in South Carolina. And now my attribute table only contains those 267 values. So from your definition query and the query builder, you had state equals SC.
I had something checked. And it's TRI for me, so that's not.
How many did get it to work?
Change the color.
Notice in my table of contents, I've turned off every other layer. So I shut off my events layer and also my geocoding results. So it wasn't showing those other layers. So once you switch those off, is it just showing South Carolina?
I didn't know that.
So if we remove that definition query, I'll go back to my layer properties, to the definition query tab. I can just delete that statement here, click OK, and they all come back. So this is a nice way of building in a filter to your data. All right. So next, let's build some more advanced queries. So as we examine our attributes here, notice we have these Chem1, Chem2, Chem3, Chem4, and so on. And let's say I'm trying to find some subset of my data, and I'm trying to identify the major releasers of the chemical toluene to the environment in South Carolina. So toluene has some fairly nasty properties to it, and I want to find just those facilities where the top 1 or 2 chemicals they release is toluene. What is our statement going to be to select those records?
So it is only in Chem 1?
No, it could be in Chem 1, Chem 2, Chem 3, Chem 4, or Chem 5.
M1 or M2 or all of that, I assume. And then equals.
Yep, so we know in this example, we're only interested in Chem 1 and Chem 2. So having toluene in the top two chemicals. So Chem 1 equals toluene or Chem 2 equals toluene. But I'm also only interested in South Carolina. So what else do I need to add to the statement?
Parentheses.
Parentheses?
They say equals SE and or.
Yep. Yep, so we'll use parentheses to make multiple statements, and we're going to combine them with an and, right? We need both of these things to be true. So let's go to our attribute table, and then notice here in the upper left corner is a select by attributes. I can click on that to open my select by attributes window. So I know I can access it from the selection menu or from the table itself. So our statement here, first let's identify those in South Carolina. So state, double click on state, click equals, click get unique values and double click SC. Then I'll click and now I want to click this parentheses because I'm going to evaluate two statements together. So now I'm going to scroll down in my dialog till I find Chem 1, double click Chem 1 equals, click on get unique values and scroll down in my long list until I find toluene, Toluene. And then click or, double click Chem 2 equals, get unique values, scroll down until I find toluene again. And then I want to click verify and make sure there's no typos. So mine was successfully verified. Just to demonstrate, if I insert a space between the parentheses and Chem 1 and click verify, it's flexible enough that it worked. If I introduce a space after toluene for Chem 1 and click verify, it seems okay as well. Just trying to break it here, and I can't do it. Anyway, once you've applied that change, how many facilities do we have? I get 21. I run it. I also get 21. All right. All right, I can clear my statement. If I click clear, that will remove any statement. What?
I'm comparing to her statement, but there's no equal sign.
Click in here.
Yeah. Thank you.
All right, let's try out some other functionality then. Let's quickly close our select by attributes window. I'll clear my selection. And let's try using a wildcard. So let's say I'm trying to find a specific facility and I know it's in a city that ends with Boro, B-O-R-O. but I can't remember if it's Waltersboro or Murfreesboro or one of the other boroughs around. So let's try that query here. I'll open my select by attributes window. I'll clear my statement. And now I want to select from city. So I'll double click city. Like. And here I'm going to actually type in what I want. So here I'll type a space, single quote, %, and capital BORO, single quote. And then I want to verify. Tells me it was successfully verified. So how many cities do we have to choose from? Or at least how many facilities are in cities that end in borough? 12. See, I see 12. And what are they? I'm going to click on show selected records in my table. I see Toomsboro, Greensboro, Swainsboro, Waynesboro, Mooresboro, Roseboro, and so on. So I'll clear my selection, open that up. So again, I've typed city, like, single quote, %, capital BORO, single quote. So if I try lowercase and I verify, it tells me the expression was successfully verified, but no records were returned because this is looking for lowercase BORO. It is case sensitive. So what would happen if I add another % at the end of it? How is that search going to be different than the first one? It's going to look anywhere within that word as long as there's characters on either side. So if I apply that one, I get just 12 records returned. So there isn't some city called Borrowsville or something like that in our data.
Yeah.
So if we do this one instead.
Well, I was thinking with the percentage times too. Like percentage time.
Like this. Here we're kind of mixing, but let's see what we get. So it will look anywhere on this side plus one additional character. So we're really just being redundant and specifying it here. How do you guys feel about querying? Feel pretty confident? So how would you guys want to use this after you leave today? What would you be using selection for? Any ideas? Who knows right away they'd want to walk out and start selecting and querying their data?
Create a query and selection and export only those data observations. I don't see myself using that.
Yeah, that's something I've done very regularly is make some selection in my data with some query. For an example, if I just want those states in South Carolina or those facilities in South Carolina, and I want them as their own data set, I set up that query and then I export the data to a new shapefile or feature class. So that's very, very common. Any other ideas? No? All right. I'm going to clear my selected features. And just note that some other things we might want to do is, say, perform some sort of geoprocessing tool. I know we haven't gotten there yet. I'll get a bit ahead of myself. But if I want to, say, find facilities that released some particular contaminant and I wanted to calculate their distance to the nearest stream, I could subset those features that released contaminant X, whatever it is, and then use a tool with some streams data, and it would only return those distances for that particular step. So we can restrict our analysis as well. I think everybody's signed in. Whoops. So we feel pretty good about querying. Yep, question.
I'm trying to, I'm just making things up, but I'm trying to say with like not looking at states, just like Chem 1 or Chem 2, like compounds, because I'm looking for any kind of compounds. How do I get, whenever I try and do Chem 1 or Chem 2 prior to the like or equals or anything, I get errors.
Let's see.
Do I have to do independently?
What am I doing wrong here? Here's a very useful tool for the ArcGIS user is click help anytime you need it. Right, so I'm going to look through quickly, find, search through. Sorry, so which one of them were you trying to run again? Which one were you trying to evaluate again?
Well, we figured it out. So I was trying to search for like we did before, right? Any compounds within Chem 1 or Chem 2. But I was trying to like write it out like Chem 1 or Chem 2, like, and identify both of the columns within which I'm searching first, or is it one to do two separate?
You need to specify the values for each attribute field.
Yeah, like independently.
Yes.
And say like within all three fields, I'm looking.
Right. Yeah, you need to say what each of those fields needs to be equivalent to for it to work. Okay. Okay. Sorry, I misunderstood your question.
No,
So.
it's
All right, let's go on to our next topic then, joining tables together. So this is a really powerful thing we can do here in GIS, where we can link tables of attributes to one another. So we can bring in new information to existing data. So for example, you might find out there some really boring geometry, right? You can go to an Atlas website that serves basic GIS data, and it may have polygons representing here all the counties in Oregon. No information about those counties whatsoever, just some boundary layers. You can also have a table of information with some boring statistic information, and you want to make a map out of that table. You want to, say, visualize some sort of demographic data or health data or whatever it is for each of these counties and make a map from it. But here we just have a table. We can join a table of information to an existing polygon layer, in this example, to make our geospatial awesomeness. We can link tables to one another without any geometry, and we can also link attribute tables from, say, one polygon layer to another. So the way this works is that there needs to be some field between the two tables that links them together, something that's common to both of these tables. So this is a really powerful way to expand your geospatial data. So these joins are based on this common field called a key field. The type of field in that key needs to be the same in both cases. So that means that they both need to be text fields or they need to be numeric fields, but we can't mix and match text and numbers. The field data should be representing the same thing. So what that means is you wouldn't want to have a code for, a zip code and a FIPS code and try to link those together because they're not the same type of data. So the join is dynamic. Remember, our events data set is a dynamic data set that only lived in the map document. So is our join. It only lives in the map document. You can export a data set to preserve a join, and the exported data will have those appended attributes. But here, in our example, we're starting with some table that only has an object ID, some automatically generated code, and then this land use code. And we have another table that has a land use code and a type, what those codes actually mean. We can join together and match that land use type based on our common land use code. So our joined table here, which have this output shown at the bottom. Make sense? So joining in GIS or when working with databases is possible only when there's a specific cardinality or a basic relationship between the two tables. So the terms shown here are the destination table and the source table. So imagine that table A, our destination table, is the one that's already in GIS, and we want to bring in new data, this new source table. It's our source of new information. So we're going to try and match records from our source table to our destination table. If there's a one-to-one cardinality, what that means is that each row or each record in our source table will match only one in our destination. So here the example would be, I have polygons representing states, and I have a table with information for each state. So I have 50 polygons in my destination. I have 50 rows in my new source table. Each one matches one and only one feature. And I can join my tables together. A many-to-one cardinality means that there are many possible destinations in our, or many possible rows in our destination that match one in our source. And every time there's or each repeated instance in our destination will repeat information from the source. So going back to my example, let's say my table A destination is now all the counties in the United States, and my table B is state level information. The relationship is clear. I can match that state to a county within the state, and then I'll just duplicate that state level information for each one of those counties. That makes sense? That's a many-to-one relationship, and we can still join tables together. If there's the opposite, a one-to-many relationship, then there's no clear association between the two. If I flip my states and my counties, now I want to try and append data from a county to a state. Which one of the counties do I join to that one particular state? There's no clear relationship between the two. So what we can do is still establish a relationship actually called a relate. So it's a linkage between these two tables where you can make selections on one and see the related features. So I could, for instance, select a particular county in South Carolina and then access that related state level information in my other table. A many-to-many relationship, you can now imagine, where multiple values in each table may match multiple records in the other. And we can still build a relationship this way. Questions?
Do we kind of avoid those many-to-manys in most cases?
I mean, it depends on what you're trying to do. If you need to append information, then it has to be a one-to-one or a many-to-one. In some cases, your data may not make sense to join. For instance, if you have, say, aquifer data, so these rock units that carry water, and you have a lot of wells that are all pumping water, you can't join the two tables together. But through a relationship, if you wanted to quickly identify all the wells in this particular rock unit, you could select that and identify that subset of wells. Other questions? All right, let's test you on it. Here's my destination table, where I have country as an attribute and a government ID. And I see these entries, France, Sweden, and the UK, and the government IDs 1 and 2. From my source table, I also have a country, France, Sweden, and UK, and a capital. So what's my cardinality between the two? One-to-one. So can I join these or do I relate them? We can join, right? Because every one of these in our country fields match. We can link France to France, Sweden to Sweden, and the UK to the UK. Here's another source table where I have my government ID codes, and now I see that a 1 is telling me it's a republic and 2 a constitutional monarchy. If I wanted to, what's the relationship between the two? It's a many-to-one, right? There are many rows over here in our destination that match 1 in our source. So we can simply repeat that constitutional monarchy information for Sweden and the UK. How about here? We have countries, and then we have major cities within those countries. What's our relationship? Right, it's not clear now. I have, say, 1 over here, France, that matches many in my destination table. So which one do I pick? Bordeaux, Marseille, Lyon? I can only relate them. So here's a snapshot of what it looks like here in ArcGIS. We have census level data down here, where this STFID, state FID, is a code that matches state FID in my above table. My above table would be some polygons for each state. And now I have population and demographic data. So using that key field and my join data dialog here, we choose which tables we're attempting to join. And then through these drop downs here, we specify what the field is that links the two. And there's this really useful option to verify or validate, which I'll get to in a second. And our output join data table has all that information from both tables. That validate join option is really, really powerful because it's just like verifying your query. It's going to alert you to any problems in your join. So it's going to look through your tables and check for all those special characters in your field names. It's going to check that entries between the two fields are consistent. So are they both text? Are they both numeric? Do we have an exact match right? As we saw, things are case sensitive. Lowercase c California is not the same as capital California. It will alert you to access database reserved words. These won't always cause a join to fail, but the software based on the Microsoft Access format doesn't like to see a long list of words as the names of attribute columns. So date, day, month, table, user, when, where, year, zone, and so on. So this validation report tells you how many records between the two tables matched. So again, it'll let you know if nothing matches between the two. Relating tables has a similar dialogue to it, but rather than appending the two together, we specify our attribute fields that link the two, but here we're really going to have two separate tables rather than seeing this joint attribute data. So, any questions? No, let's do it. Let's dive in. Let's go and open ArcMap again. I'm going to close my attribute table here. I'm going to go to Arc Catalog here on the right, and we're going to work out of this joins and relates map with that .mxd extension. So we can double click, open that, and we don't need to save any changes to our current map. So I'll say no, don't save changes to the untitled map. So we're going to work with some different data for the state of Oregon. We have polygons that represent counties and census tracts. We have tables at the county level, at the census tract level. And so we're going to do all sorts of joining and relating between the two. Close my business analyst window here. And once your map opens, go ahead and open that attribute table for our layer. So our layer here, this OR tract 2010, these are polygons representing census tracts in that state. And then just take a look at what sort of information we have about each of these census tracts. I'll right-click my layer, click Open Attribute Table. What sort of information do we see? Anything interesting? Not really, right? So we have all sorts of IDs in here, right? This is an example of a data set you might obtain where all it contains is geographic boundaries and some codes. So let's go to our Working with Tabular Data folder and expand your Joins and Relates geodatabase. So click that plus sign next to the Joins and Relates geodatabase. Notice there are a few geodatabase tables stored within it. We have this one, OR tract tables. So let's add that to the map document. Click to drag and drop it into my data frame. I see my table of contents changes to that list by source. And let's open that tract tables by right-clicking it and then click open. Everybody there? Need to see anything again? Okay, so from Arc Catalog, I went to the Joins and Relates geodatabase in the Working with Tabular Data folder, and I added this OR tract tables. Drag and drop that to the map, and then just open the table here at the bottom of the screen. So is there anything interesting in that table? we have some population information, some demographic data. So what we have is population for each census tract broken down across a few different races here. So we can join our two tables together, right? We have a table for each of our census tracts, polygons representing those. Let's join them. What's our key field going to be between the two? What are we going to, which of the fields in each table will we use to link these? So if I switch back and forth, GIS join, let's see, it has a G4, a lot of numbers, G4, a lot of numbers, looks good. I like the name of that field. Let's try it. So to set up a join, we're going to right click, our favorite trick, but right click on our Oregon Tract 2010 polygon layer, and then select this option, joins and relates, hover my mouse, and then click on join. Did the sound come back? My microphone isn't muted. Let me know if you can hear me.
I think it's about it. That's good.
So I'll right click again on my Oregon Tract 2010 layer, hover over joins and relates, select join. So we're going to join attributes from a table. Here under option number 2, we can select another table from our map. Our only option is Oregon Tract tables. So for option 1, we need to choose the field in our tract polygons layer that matches. So we'll select GIS join. And then the field automatically finds GIS join in my other table, right? It's going to make a guess that this is the one I want. Our options are we can join all records or keep all records. So anywhere it does not link an entry, it would keep that information, but just populate any empty attributes with a null value. Or we can keep only matching records. So if there was only, say, 2 features that match between the two, the output would only have 2 features. We'll select the keep all records and then click this validate join button and take a look at the output. How many of our records match between them? So 827 of 827 records matched. It's letting us know that there's a field called year, which may cause problems, but let's see. I'll click close and then click OK. And now as I scroll through my attribute table for my tract polygons, I see all that other information. Right, here's all of that population data from my tract tables. Did everyone get that to work?
You have a lot of observations for validate join. Should you just always do that? Or you got like a ton of points that you kind of, that take a long time to validate?
It may, but I would recommend doing it because it will let you know what didn't match or any other problems. Or if the join simply won't work, it will tell you. So if you anticipate all of them matching and none of them do, this will let you know ahead of time. The most common cause for that is if you have a field where one is text and one is numeric, and you don't know ahead of time, you would think it would go and match them all, but it would not. All right. So everybody got this join working? let's see how we remove it then. Right, this is a dynamic join. We can remove it by right-clicking our Oregon Track 2010 layer, hover over Joins and Relates, then go to Remove Join, and click on either Oregon Track Tables or Remove All Joins. And I can see instantly all those lovely new attributes we had a second ago are all gone. But if I can quickly add them again just by right-clicking my Oregon Track layer, go back to Joins and Relates, select Join, my GIS join fields, and then click OK and restore it. So what was our cardinality between these two? What's our relationship? 1-to-1. Yep. So one feature in our track table matched one in our polygon layer. You right-click the Oregon Track 2010 layer, hover over Joins and Relates, click Join, and then I needed to select that GIS join field between the two tables. So let's try, we just tried a 1-to-1, let's try a many-to-one join, right? Where we're going to have some other table where each census tract that's unique to one boundary or one particular zone will repeat that information. So we're going to bring in county level data for Oregon. So here we have a table in that joins and relates geodatabase called Oregon County Pop Change. So let's drag and drop that into the map and then open it from the table of contents over here. So I'll right click it, click on open. So here I see a couple of fields, the unit, which is the name of county, and I have populations in 2 different years, the change between them and that change as a percentage. So let's join this population change table back to our census tracts. So I'm going to right click my Oregon Track 2010 layer, go to Joins and Relates, select Join. And here I'm going to select for number 2, that Oregon County population change. What were the fields that we're going to use? I'll close my join window and you can look up here. What fields do I have in common between the two that I could now use? There's a county field in my track 2010 layer and the unit, which is the name of that county. So those are the two we're going to use. So right click Oregon Track 2010, open my join window again. So my option 1, I want to find that county field. And it automatically suggests the unit from my second table. So my join options will now be to keep all records again. Let's validate our join and see if we have any problems. How many matched this time? All 827, right? It's just letting us know it also doesn't like the names, number, and percent for fields, but we'll click close, click OK. Go back to our Oregon Track 2010 layer. I'm going to freeze my county column. So I'll right click that county column, select freeze, and then scroll all the way over just to show that that number and percent and all of these fields are just duplicated for every census tract in the same county, which is exactly what I would expect to see in this many-to-one relationship. Does that make sense? Everybody able to set that one up? So what else is unique about this join? Was it possible before we joined our tract tables to it? So our Oregon Tract 2010 polygons did not have that county name in it. We first linked up the GIS join code to identify these, and then we're actually using the name of the county from our Oregon Tract tables layer. Right, so this second join wasn't even possible till we did the first. So sometimes compound joins are necessary to link data from one table to another. Another thing we can do with tables is aggregate data. So let's say we want to combine information from one level and summarize it or aggregate it to another. So we have population data for every census tract here in Oregon. What if we wanted to sum each of those census tracts to get a county level population? We can aggregate based on that county name, and we can perform a variety of operations. So here we could, for instance, sum every value in our total population everywhere county is the same. So everywhere it says Baker, for instance, it will add up all of those component populations, and we can output that to a new table. So every county will have one population statistic. So what we want to do is let's go to our Oregon Tract tables table. So if you've closed it, we can right click here in the table of contents. On our Oregon Tract tables, click open. And we want to go to the county field, right click on it, and we're going to click on summarize. So what we want to do is select all of the fields from that table to summarize. So if we scroll down in our list, we're going to find this total field. And if we expand that, you can see it can calculate and output a variety of different things: minimum, maximum, average, sum, standard deviation, and variance. We want the sum. We're adding up individual populations from each census tract to get the total county population. So I'll click the sum for the total and then do the same for the rest of these population fields. So I'll go to my white, sum, black, sum, American Indian, sum, and so on. And we'll specify our output table. I'm going to browse to my Working with Tabular Data folder, back to that Joins and Relates geodatabase, double click on it to enter. And I'm going to call this sum county, SUM_county. Click Save and then click OK. And we can add our resulting table to the map. Go ahead and open that one. So right click, click Open. Now I see there's just one row for each county. I have a field telling me how many individual records went into that. So for instance, Baker had 6, and then it gives me the sum of all of those fields. So for instance, if now I want to bring in my Oregon County 2010 polygons over here in my Joins and Relates geodatabase, the only problem is I need some code, but I have a name field here. So we can then right click our counties, go to Joins and Relates and join. Select the name 10 field, and then the county field. Let's validate. We get 36 of 36 that match. Click OK. Now we have all that population, so I can go in and do things like symbolize. I'm just going to do this really quickly. Some quantity, say total population, flip my symbols, and now I can map that population at the county level that originally came out of a census tract level data set, and appended that summed population back to polygons that didn't even have that information to begin with.
Can you walk through that again?
How did I do that? Which step, right?
So brought in the polygon.
So I brought in the polygon, set up the join, and then symbolized it. We can come back to it. I meant to do it really, really fast. Let's go, I'll turn this layer off and go back to my census tract level data. Let's say I wanted to make this join permanent, right? So I don't lose all that population level data. Where did I want to go to do that? Right click on it, go down to data, export data. So we'll export all features using the same coordinate system as the layer. Save my output by browsing. Look in my working with tabular data folder, the joins and relates geodatabase. And I'll call this OR underscore tract underscore population. And click save, click OK, and I'll add it to the layer, or add it to the map, just to show that attribute table now permanently has all that information joined together. So what do you think? Joining tables, is it difficult, easy? 1 to 10. 6? Fairly complicated? Yeah, you always go back to that same dialogue, but the requirements for this to be successful are much higher than other operations. Yes. It's very easy to create garbage or try to feed garbage into it and it won't let you match that. Yes. Yeah, exactly. Exactly. So again, there's a lot of data cleaning and preparation to make joining work. Let's take a look at relating some tables to one another. So I'll turn off my new layer here. If you haven't already, let's go back to the joins and relates geodatabase. Drag and drop that Oregon County 2010 layer to the map. And let's also add the Oregon County population change table, OR underscore CO underscore pop underscore change. So if I right click my OR County 2010 layer, go to my joins and relates, and rather than select a join, let's click on relate. For option 2, let's select, rather than the OR track tables, go to that Oregon County pop change table. We'll use the name 10 field from our county layer, and it will match that with the unit. And then click OK. So I'll go back and remove it to show it again. So I have my Oregon County 2010 layer. Go to joins and relates, click relate. I'm going to join for step 2, Oregon County pop change. For step 1, I'm going to select the name 10 field, and it will fill in unit down here. And then I'll click OK. You can give a name for the relate. We'll just accept relate one. Click OK. Now I'm going to close my attribute tables. And let's just open our Oregon County 2010. So right click, open attribute table. And then right click and open Oregon County pop change near the bottom. Click open. And let's see if I can get this to work. So if I click on one of these tabs in the lower left corner, I can move around and dock the tables next to one another. So I can view two tables simultaneously. So now if I select one record, notice there's been no attributes appended between the tables. If I select one subset of records here, and then click this button near the upper left corner of my table that says related tables, and then click relate one, it's going to push through that selection to the related table and show me those related features.
That showed the related feature.
Yep, I'm going to clear my selection and close my table. So I'm going to open just my Oregon County 2010 layer, attribute table, and open Oregon County population change. And if I click and drag that tab at the bottom, I can see different places. To move it, I'll drag and drop it here on the side. So I see them simultaneously. And now I can click and drag here on the left in this gray space to these small gray boxes. I can click and drag to select these features, and then click this related tables drop down here and click on relate one. And that will push through that selection to the other table. So what I should see here is that I have, let's see, 9 and 9 selected. These are both county level tables, right? So they do have a one-to-one relationship, but here it's a nice demonstration that once I've selected this record representing Morrow County, it's also grabbing Morrow County from my related table. So if I clear my selection and select only Morrow County, and then push through that related, we'll grab just that feature. So they could have a one-to-one relationship, a one-to-many, or a many-to-many between the two. But now there's this established relationship between the two, and I can select one feature and find those related features. Questions? No? All right. Well, that is all I had for today. So I'll release you plenty early back to your Thursday afternoon. If you could please go to this URL at bit.ly/ccgt survey, provide feedback before you go today. I'll email out the materials from today, as well as a link to the YouTube recorded video for all of you. Whoops, went too far. So hopefully you've already reserved your seat for next week. So tomorrow and following Thursday, we're going to have basic spatial analysis as our next workshop. So this is going to focus on how do we use different geoprocessing tools to perform analysis on vector data. So we're going to analyze things like overlay. So look at and identify features that lay on top of one another on the Earth. I quantify how far or near things are from each other, do spatial joins. So today we've joined information from tables. We can also join features based on their locations, as well as a number of other things. So it'll be pretty good. We'll have it tomorrow afternoon and next Thursday. So hope to see you all there. I'll be hanging around if you have any other questions you want to ask me, but thanks for coming. Did everybody get a chance to sign in?
All right.